Section 11, Topic 2, we're going to be talking about how to find the area of polygons. And these aren't just going to be like squares and triangles because those are basic equations like base times height or half base times height. We're going to be looking at pentagons, hexagons, octagons, any sided regular polygon. So how we're going to do this is we're going to break these shapes into smaller triangles. Like the example that I have below is of a pentagon, and we're going to break it into triangles. So there should be 5 triangles that make up this shape, and we're only going to look at just one of those because once we find one triangle, the area of one triangle, we just have to multiply it by 5 because this would make 5 triangles in this 5-sided shape. And we're going to use trig to do this because it's not always clear what the angles or the sides of the triangles are. So I just want you guys to remember that sine is opposite over hypotenuse, so the opposite side over the hypotenuse. Cosine is the adjacent side over the hypotenuse, and tangent is the opposite side over the adjacent side to whatever angle you're trying to find. Again, remembering that in the area of a triangle is half base times height. And then maybe a new vocabulary word for you, apothegm. It is the height of a triangle. So what we're going to do is we're going to first find the interior angle of our pentagon. So again, we've learned this formula in semester 1. It's 180 degrees times the number of sides minus 2 divided by the number of sides. That's going to give you just one interior angle. All right, so to calculate that interior angle, again, we're going to take 180 degrees times the number of sides, which is 5, minus 2, divided by 5, again, the number of sides. When we do that, we get 108. So that's each interior angle of this regular pentagon. So I'm going to go ahead and label 108 in all of the angles. But if you notice, the triangle that we created, it actually bisects the angles. So it cuts this angle in half. So half of 108 is going to be 54. So each of these angles is 54, while the whole angle is 108 still. Next thing that we need to know is that this 2.5 is, since it's a regular shape, is the same measurement all the way around our pentagon. But when we get to the bottom, the apothegm, the height, is going to cut that in half. So it's going to be 1.25 for each of those little triangles. So to calculate the apothegm, we need to determine what measurement for this right triangle, again, remember this is a right triangle inside this pentagon, what trig function are we going to have to use? We have the 54 degrees, we have the side that's right next to it, so we have the adjacent side, and we're looking for the side that's across from the 54 degrees, so that is the opposite side. So if I'm looking for the opposite, I have the adjacent, that's going to be tangent. So tangent of 54 degrees is going to equal the opposite, A, over the adjacent side, which is 1.25. Because the number is on the bottom, we can easily just cross multiply, and we'll be doing 1.25 times tangent 54, and that's going to equal our apothegm, which is 1.72. So again, the apothegm is 1.72. That's the height of the triangle. Lastly, we're calculating the area of not only just this one triangle, but all 5 that are in the pentagon. So the area of the triangle is half base times height times the number of triangles that we have, so times 5. So the area is going to be half the base of the whole triangle. This whole triangle is 2.5 times the height, so times the apothegm, times 1.72, times the number of triangles that are made up in this shape. So we're going to multiply it by 5. So when I multiply all 4 of these numbers together, the area ends up being 10.75 inches squared.